Thank you for joining the climate-related financial and business risk conference today. As an old Chinese proverb says, may you live in interesting times. And I'm sure you can attest to the fact that we're truly living in interesting times now. On an occasion like this, with such a big conference, we would have been sitting in a physical environment, sipping some coffee and socializing. However, we are here on webinar due to COVID-19. In fact, COVID has showed us the importance of climate change and that we cannot leave it to the last minute. It has to be tackled urgently. I am not one to make a lot of big speeches. I want to leave today's panel, I want to leave a lot of the talking to the panelists today. And I'd like, before we start, I would like to have some few housekeeping rules. Firstly, all the participants are on mute except the speakers, you'll be able to, except for the speakers, you'll be able to hear us speak, but the participants will not be able to speak. You can ask questions through the Q&A button here, and then we will answer your questions accordingly. The way the webinar will be structured will be as follows. Each presenter would have 20 minutes followed by 5 minutes question. And then we will move on to the next presenter and it will follow in that order. After all the presenters have spoken, we would have 10 to 15 minutes max question and answer. We will select the questions from the questions that have been submitted, either now or previously, and then we will answer it. If we are not able to answer any questions, please bear with us. We will try and answer it after the webinar. Or you may get other answers as well throughout the whole conference. I would also like to say that even though the webinar has been booked for 2 hours, the webinar would rather be for 1 hour and 30 minutes. The extra minutes have just been used to cushion any internet issues that we may experience. And I hope that today we do not experience any internet issues and everything works out well. So I would like to now introduce the panel that I have. The first person that I have is Professor Miles Allen. Professor Miles Allen is the Professor of Geosystem Science at the University of Oxford. He has spent over 30 years studying global climate change and trying to work out what we can and cannot predict. I'm sure you've Googled Miles and you've seen him a lot. He's all over Google. And Miles is the one that worked out that human influence has actually contributed to climate change. We are also joined again by Tim Kruger. Tim works on the Oxford Martin post-carbon program. He today would also be talking about carbon capture storage. We followed by Pauline Anneman, who is an ex-Oxford University student currently working at the Africa Energy Center in Ghana. And I thank you all very much for joining us today. So without much ado, I leave the first session to Professor Miles, who will be talking about 1.5 degrees, the science behind it, and also how do we get to net zero? That has been some of the biggest questions that we've been receiving now. So thank you very much, Professor Miles.
Thank you very much, Rachel. And please feel free to say on the Q&A if you can't hear me very well or if there's a pause, and then Rachel can intervene and make sure that you can get all this smoothly. I'm delighted to be able to talk to you today in this way because net zero is a really important issue, particularly for Africa. It's the continent which is really going to shape our century in the second half of this century, and decisions that you're making today in various parts of the African continent are going to determine whether we achieve net zero this century or not, whether we achieve our climate goals set out in the Paris Climate Agreement. So what Rachel asked me to do was to just give you an overview of what climate change is and where we're going, and focusing in particular on what we need to do to solve it. So I sort of gave myself the title, Solving Climate Change, and I'll just share the screen now. And so that you can see some visuals I've got.
Yeah,
and here we are. And just confirm, give me a thumbs up, Rachel, if my screen share has gone all right.
Yes, your screen shares.
Excellent, good, okay. So as I said, I'm going to talk about sort of what it'll take to solve climate change. And most of what I'll be saying is drawn from the recent Intergovernmental Panel on Climate Change special report on 1.5 degrees, on which I was a co-author. And one of the key findings, of course, of that report, it wasn't new to that report, but it was reconfirmed in that report, is our world is unequivocally warming. We see global warming, we see the impacts of global warming across all continents of the world, in all regions, and in all inhabited parts of the world. And we know what the main drivers are of this warming. We know what is causing this warming. Part of them, one which people like to talk about a lot, are natural. The sun, the power that emerges from the sun warms our planet. That goes up and down from decade to decade, but it tends to go up and down just over a sort of 10-year cycle. It doesn't vary much from century to century. And in fact, over the past 30 years, since we've got really good satellite observations of the sun, the power output of the sun has, if anything, been going down. So we can't really explain the recent warming as a response to changing power output of the sun. We also have occasionally cooling of the world by large volcanic eruptions. The most recent one was Mount Pinatubo in the Philippines. But again, these drivers of climate change cause a temporary cooling of the planet, but they can't be used to explain the long-term warming that we see. The driver of that is clearly the changing composition of our atmosphere due to rising greenhouse gases, which is also to some extent affected by other forms of pollution like aerosols. And we use what we know about the way when these emissions have been produced, when these aerosols have been produced, to understand what is driving the increase in global temperatures. And you can see on this screen how different drivers of climate add up to give us the warming we observe. Crucially, we work out how different drivers contribute to the observed warming. This doesn't depend on climate models. It depends simply on our understanding of what these drivers are, when these emissions occurred, and how the climate system responds to them. There's plenty to criticize in climate models. I work with climate models all the time myself, but it's important for people to understand that our understanding of what is happening to our Earth's climate goes back long before we relied on these very complex climate models to model the world's climate in detail today. We need models to understand the details of what is happening, but we don't need models to understand the big picture of what is causing the warming. So where are we at? We've reached 1.1 degrees. We're warming at over 0.2 degrees per decade. And there's some uncertainty in that, plus or minus 20% or so in the level of warming we're at the moment. And at the rate we're going, we've already crossed the 1 degree line. We crossed it sometime in this past decade. And you don't have to be, it's not very complicated maths to work out that we're likely to reach 1.5 degrees at this rate well before 2040. That's a global number. So it's very important to remember that this warming is not uniform across the globe. And in fact, this map shows where people live in the world, and it shows how much it has already warmed in these regions of the world where people actually live. And you can see that for much of the world's population, including many parts of Africa, we've already seen a warming greater than 1.5 degrees in at least one season of the year. And this is the change in temperature that people actually notice. Nobody experiences the global average temperature. They experience the seasonal temperatures where they happen to live. And in a continent like Africa, where for much of it, year to year temperature fluctuations are not very large, a warming of more than 1 degree has profound impacts on both human societies and natural ecosystems. So we're likely to reach 1.5 degrees sometime between 2030 and the early 2050s if temperatures continuing to increase at the current rate. And I'd like to go on from here to talk about what this means for climate impacts, why we should be, what our reasons for concern are about temperatures rising. Well, the crucial point to take away is that the risks of climate change, the impacts of climate change, all rise with the level of global warming. So the warmer it gets, the greater the risks, both to human systems and natural ecosystems. And in the 1.5 degrees report, we divided up these risks into different categories: unique and threatened systems at the one end, all the way through to large-scale singular events, that meaning large changes, global changes triggered by global warming at the other. So an example of a unique and threatened system is coral reefs. This was one impact that was drawn out by the IPCC special report on 1.5 degrees as particularly vulnerable to a small level of warming. There's a reason for that. Corals live in warm tropical seas where temperatures don't vary very much from year to year. So up until sort of before 1980, there were no reports anywhere in the world of mass coral bleaching events. That's an event in which all of the little organisms which support the coral actually get driven out of the coral by the higher temperatures, and the coral turns from those beautiful colors that we've all seen, or if we have been lucky enough to visit these reef systems, experienced, it turns white, and hence the bleaching word that's used to describe this. The corals can sustain a single mass bleaching event, but when a succession of bleaching events happen year on year, the coral can sustain then irreversible damage. And the first report of a global mass bleaching event was in 1998, when the global temperatures had reached around 0.6 degrees above pre-industrial temperatures. In this decade that's just finished, where temperatures have been around 1 degree above pre-industrial, we've seen the first back-to-back global mass bleaching events, which actually kills the coral off. It no longer recovers after a back-to-back bleaching event. So we're starting to see irreversible damage done to the world's corals. And the estimates in the IPCC 1.5 degrees report were that at 1.5 degrees, we sadly will lose over 2/3 of the world's warm water corals. And by 2 degrees, they'll be 98% or so gone. Another impact which people are very concerned about is the impact of climate change on extreme weather. Here, we're sort of earlier in the stage of impact than we are with coral reefs. Up until the year 2000 or so, there were no reported detectable impacts of climate change on extreme weather. It's important to say there weren't any reported. Doesn't mean there weren't any, but it's just the academic understanding in the world's universities of how climate change interacts with extreme weather just wasn't there to make that link. So it was early in the 2000s that we first started, some of this work actually was pioneered here in Oxford, that we first started making a quantitative link between human influence on climate on the one hand and actual harmful cases of extreme weather on the other. And now, only barely a decade on, we are now at the stage of reporting annual assessments of the role of human influence on climate in all kinds of extreme weather events, including heat waves, storms, floods, droughts, and wildfire. Not all extreme weather events are being made worse by climate change, but many of them are. And crucially, the patterns of extreme weather are changing. And that's important because the infrastructures we have, the economies we work in, the ecosystems we depend on, are all adapted to the patterns of extreme weather that built up over the Holocene period, over the past 10,000 years. And these rapid changes in the nature of extreme weather is already having profound impacts on human and natural ecosystems. And now to get on to the economic impacts of climate change. I focused on some ecological impacts so far, and this is where the picture across the world is crucially very uneven. So one of the crucial conclusions of the 1.5 degrees report was that the impacts of climate change would be concentrated in tropical and southern hemisphere subtropical regions, which would be expected to experience the largest impacts on economic growth due to climate change at 1.5 and 2 degrees of warming. So what you're seeing here on the map in purple are countries that experience a significant decline in their GDP growth, in their economic growth, as a result of only 1.5 degrees of warming relative to the present day. So it's just an extra ½ degree of warming on top of where we are today would be enough to slow down economic growth in those countries that you're seeing on this map. And this is based on, not on modeling, but on an economic analysis of economic data from these models, from the World Bank over the past few decades to relate changing economic productivity with variations in temperature, and taking into account, of course, the country's circumstances and also their climatic conditions. At 2 degrees of warming, we see a much more prevalent picture of economic impact across the tropics and southern extratropics. We also interestingly see a few cases of green countries appearing, where countries are actually seeing some local economic benefit from the warming. These tend to be very cold countries where they find they need less energy for heating because of the warming due to climate change. Now, that doesn't mean, of course, that those countries, Canada is an obvious one here, will necessarily benefit from climate change because, of course, we live in an interconnected world. And Canada depends on imports of food and other commodities from Africa, from Latin America, from India, and so on. And so adverse climate change in one part of the world affects supply chains, which has a knock-on effect on people everywhere. So in the light of these emerging impacts, we agreed in the Paris Climate Agreement, the world, all 190 countries of the world signed up to hold the increase in global average temperature to well below 2 degrees above pre-industrial levels, and to pursue efforts to limit the temperature increase to 1.5 degrees. So what does that mean? What does it mean to pursue efforts to limit the temperature increase to 1.5 degrees? So at this point, I'd like to introduce an analogy for you to remember and take away with you. The idea of a climate breaking time. So those of you who can remember your driving test, which I'm sure everybody can. It's always very traumatic getting your driving license. One of the things we had to learn was braking distances and the time it took to stop a car traveling at different speeds. So if you're driving along and you realize it's 15 seconds before you reach a junction, and if you start braking now immediately, then you have 30 seconds to stop. If you stop smoothly, to stop at the junction. If you go away, why is it 30, not 15? Well, you're slowing down. I'm sure you can go away and read your notes for your driving test and remind yourself that that is true. Well, exactly the same logic applies to climate. If it's 15 years before you reach 1.5 degrees, then you have 30 years to stop the warming, to keep temperatures below 1.5 degrees, if and only if you start reducing emissions now. So on current trends, as I pointed out at the beginning, we will reach 1.5 degrees before 2040. So we need to stop the warming well before 2060 if we're going to meet the 1.5 degrees goal. So that's a very simple logic, which leads us to the conclusion that we need to be aiming for net zero to stop the warming by mid-century if we're to meet the goals of the Paris Climate Agreement. So this is, what does it take to actually stop the warming? What does net zero mean? This was one of the questions that came up in the questions which were sent in prior to this seminar. Well, the 1.5 degrees report is very explicit on this. Reaching and sustaining, that means maintaining over many decades, net zero global anthropogenic carbon dioxide emissions. Okay, that means everywhere in the world, any ton of carbon dioxide emitted has to be balanced by another ton of carbon dioxide taken out of the atmosphere by human activity. So that's what we mean by net zero global anthropogenic carbon dioxide emissions. That's one thing we have to do. And we have to sustain declining net non-CO2 radiative forcing. These are the words of the Intergovernmental Panel on Climate Change. I apologize for the jargon, but basically that just means the net warming impact of other stuff. So these other things like methane emissions, other forms of pollution, can affect global temperature by up to 1/10 of a degree either way. We obviously have to make sure that we're no longer causing warming from these other drivers, but the big requirement for stopping human-induced global warming is to get global anthropogenic carbon dioxide emissions, global human-induced carbon dioxide emissions to zero. And just so you can see what that means, there's a figure here which I encourage you to go and explore for yourself because it's an interactive, and it's on the IPCC 1.5 degrees website. And you can see, I'll just show you how it works. This allows you to, the top panel here, which I'm focusing on here, shows you the temperature outcome. That's the temperature we've got to already. In 2018, we were over 1 degree. We're closer to 1.1 degrees now. This is the range of temperatures we should expect to reach in the future. And this is, in this scenario, is the date at which we reach net zero carbon dioxide emissions. And you can interact with this figure to vary the date of net zero, and you can see what an impact that has on future temperatures. At the same time, you can also vary the non-CO2 drivers, the other drivers of climate change over in this panel, and see that they also have an impact on future warming. So it's an and. We have to get carbon dioxide emissions to zero, and we have to get these other drivers of climate change, what's called on this figure the net non-CO2 radiative forcing, we have to get them under control as well. We have to do both. It's not a choice. We can't do one or the other. We have to do both. And the hard one on this, the really tough challenge for us, is to get carbon dioxide emissions to zero. So I'm just going to focus now for the rest of this talk on what it will take to get net zero global carbon dioxide emissions by mid-century. So do go and have a look at that website on the IPCC site. You can follow the link in the slides and play with it yourself to get a feel for how the date of net zero affects the risk of future temperature change. So back to the presentation, let's just wrap up by talking about what it means to achieve net zero global carbon dioxide emissions. So as I said before, it means that every ton of carbon dioxide that is generated anywhere in the world is not just left in the atmosphere to affect the climate of future generations, but if it is released into the atmosphere, it is balanced by a ton of carbon dioxide being actively taken back out of the atmosphere and stored back underground, safely out of the way so that it no longer affects our climate. Crucially, in the scenarios that limit warming to 1.5 degrees, this is in the scenarios considered by the Intergovernmental Panel on Climate Change, it does not mean that no more carbon dioxide is produced. And this is particularly important for considering the implications of this for a continent like Africa. It means that carbon dioxide is disposed of safely without dumping it into the atmosphere. And this is what this figure shows, which shows the average of the scenarios which achieve 1.5 degrees in the Intergovernmental Panel on Climate Change report. And you can see there is a reduction immediately in emissions into the atmosphere. That's this dark blue line. But there is, and to begin with, that reduction is achieved by reducing the total amount of carbon dioxide we produce by investing in efficiency, by investing in renewables and so forth. But very rapidly, that's not enough to get emissions down fast enough. And we have to increasingly, as we go forward in time, rely on that grey wedge there, which is the carbon dioxide being re-injected back into the Earth's crust to dispose of it safely so that it doesn't affect the climate. And it's this technology of carbon dioxide disposal back into the Earth's crust that Tim Kruger is going to talk about in a minute. But the main part, I'm not going to talk about how this is done, but what I'm talking about here is how essential it is that we do this, because we are going to generate more carbon dioxide than we can afford to dump in the atmosphere if we are to meet our climate goals. And crucial to our climate's future is what we do with that excess. And in these scenarios, that excess is re-injected back underground, so it's safely out of the way. And that's really the choice we face going forward this century, is whether we get to net zero in time to stop the warming before we miss our climate goals. Another way of presenting this is just as a fraction that you, and the reason for this, because Rachel asked me, how can we tell if we're on track? And
yes,
looking at this fraction is a very good way of assessing whether you're on track to meet your climate goals. You can see that the fraction of carbon which we generate by energy production and industrial processes over the next few decades that we get rid of by re-injecting it into the Earth's crust, that fraction rises smoothly and reaches 100% at the point where global emissions reach net zero. It has to, that's what net zero means. It means for every ton produced, you dispose of 1 ton of carbon dioxide back into the Earth's crust. And a smooth increase in that fraction is vital for a cost-effective, an achievable transition. So, you know, if you want to get to net zero by 2050, it's actually very straightforward to say what the milestones are on the way. You need to be at around 10% by 2030, 50% by 2040, and at 100% by 2050,
100%.
which is a great way of assessing where you are. And I know there's a number of sort of companies are tracking this and are asking questions about how can we tell if we're on track to achieve our climate goals and to support the aims of the Paris Climate Agreement. And we boiled this down into 3 principles that we could ask of companies. First of all, have you accepted the case for net zero? When are you aiming to make sure that your company's activities are consistent with net zero? Do you have a profitable net zero business model? Is this, you know, have you worked out how you're going to look, how your business is going to look in a net zero world? And how are you measuring progress to achieving that? And those are the kind of questions that I think increasingly companies around the world and countries are going to have to increasingly ask themselves as we manage this transition to a net zero world.
Okay.
All right, so on that, I'll hand over to questions, and I hope that's given you some things to think about.
Good. Thank you very much, Professor Miles. This is very well done. I'd like to tell everyone that the Oxford Martin Principles, we're going to have a special webinar on that on the 18th of June. So please do register. I know that people have already started registering, and Professor Miles is going to go through it and sort of help companies and investors to understand exactly what is required. Unfortunately, Miles, we're a bit over the time now, so we have to jump to the next session. So what we'll do is we will take questions rather after the whole session. Yeah. Yes. Sorry, so without wasting a lot more time, I will now, leave the floor to Tim Kruger. And Tim Kruger is going to talk to us about carbon capture storage.
Thank you very much, Rachel. I noted that when you introduced Miles, you said that you were, people could have looked him up on the internet. I hope people didn't do the same thing with me, because unfortunately the top result for my name is not in fact me. It's Germany's #1 male porn star. So if you were expecting to be addressed by a ripplingly muscled sex god, then I'm afraid that you're going to be disappointed. If, on the other hand, you want to understand how we might be able to cure climate change, well, you've come to the right place. And so hopefully we won't have too many people disappearing on the basis of that. So I'm just going to bring up a presentation that I've got here. So hopefully you can see that. So I'm going to start with a saying, what goes up must come down. And usually when people say that, they mean it in the sense that it's inevitable that what goes up will come down. But in here, I'm talking about it must in a moral sense. If we put carbon dioxide up into the atmosphere, we have a moral obligation to make sure that it comes down again. As Miles has explained in his talk, as CO2 accumulates in the atmosphere, it's a very long-lived gas, so once you put it there, it will accumulate. It will cause climate change. So ultimately, we will need to draw down CO2 from the atmosphere. But you do have to pay for it. It's not going to be for free. So my name is Tim Kruger. I'm not from Germany, and no, I'm not moonlighting for that other role. I share my time between the University of Oxford and a technology development company, Origin Power. At the University of Oxford, I run a program which looks at a whole range of proposed techniques for taking carbon dioxide out of the atmosphere and understanding them, not just technically, but also whether they're socially acceptable. And then at Origin Power, I'm the founder and chief technology officer of a company that is developing a technology to do just that, to take carbon dioxide out of the air. Now, as Miles said, what we really need to focus on in the decades ahead is getting to net zero. And to get to net zero, we need to reduce emissions very rapidly. But even if we do reduce emissions very rapidly, that won't be enough. We will also need to store carbon dioxide away underground. And that will be carbon dioxide that is produced from the likes of power plants and industrial processes, where we capture the CO2 at that point in time and bury it underground. And also, we need to actively remove carbon dioxide from the air. And that's really the area that I'm working on and I'm going to talk about today. So there are lots of proposed techniques for taking carbon dioxide out of the air. And you can fit them into two categories. There are biological methods and engineering methods. So to talk about a very popular, but perhaps not very effective method is forestry or afforestation. And this is the idea that if we have a piece of land that doesn't have trees growing on it, we can plant trees. As the trees grow, they take carbon dioxide out of the air. And that will take some carbon dioxide out of the air, but it won't do it permanently. The carbon is only locked up for as long as the trees are living. If they're chopped down, if they burn down, then that carbon dioxide will be released back into the air. And there are lots of things that can cause that to happen. There are economic drivers, and there are also changes that are going to occur in climate anyway. So an area that could grow trees now may dry out due to climate change, and the carbon dioxide gets released back. There's also an issue of scalability. Where you can grow trees, you can do other things that we as humans value. So you can grow food, you can grow fuel and fiber, you can have that land supporting biodiversity. And so if you repurpose or purpose that land to store carbon, you may do it at the detriment of those other things. So whilst there is a large amount in the models, the integrated assessment models of forestry in there that says this is how we will balance the carbon budget, there is a danger that that budget will be balanced at the expense of food prices if it's not done properly. And you can't scale it to the extent of the problem we have. So you have an issue about scalability, you have an issue about permanence, and you have an issue about social impacts as well. Everybody likes trees. I love trees, but it's not going to be enough on its own. Another idea is called biochar, and this is where you grow biomass and then you char it, you heat it in a way that it forms this black kind of coal-like substance, and the idea is that that can be buried in the ground. And again, this will store the carbon for an intermediate period of time, but not for the long period of time that's necessary. So Miles was talking about the need to return CO2 to the Earth's crust. And that means not just at the surface layer where the soil is, but deeper than that, deep underground, maybe hundreds, thousands of meters underground. Another idea is called biomass energy with carbon capture and storage. And this is a little bit like forestry. You have trees growing, CO2 is absorbed from the atmosphere as those trees grow. You then burn that biomass in a power plant, for example, and that generates power, which is useful. And then the CO2 that is generated when you burn that biomass is captured and stored deep underground. And this would be a way of permanently storing the CO2 underground. And this again features very prominently in the integrated assessment models and is assumed that this will work. There are problems around that, which I'll come to. But again, you have a problem. How much land you have that you can purpose for growing biomass, for burning, for generating fuel and for sequestering CO2, which you might want to use for growing food, or you want to have that land being able to support a broad variety of biodiversity. So there are trade-offs here. Whether something works, it's not just technical. We also have to consider the social aspects as well. Well, if the land is constrained, what about the ocean? This is a satellite image of the coast of Europe, and that white mark there is a bloom of algae in the ocean, plankton in the ocean, which is drawing carbon dioxide out of the atmosphere as it grows. And there are many areas of the ocean that are deficient in minerals like iron, and by adding iron, you can encourage these blooms of algae. When they grow, they draw CO2 out. Initially, people thought, oh, this is a great idea. We can do this at a material scale. It turns out on further analysis that you can't do this at a material scale. And there are some very serious concerns about the biological implications of something like this. So those were the biological solutions. Now, I'd like to talk a little about engineered solutions. So this, by the way, is an artist's impression. This doesn't actually exist at the moment. Those objects that look like large fly swats are artists' impressions of machines that can remove CO2 from the atmosphere. And whilst people have made some small versions of this, and they can actually take CO2, we know you can take CO2 out of the air. I mean, it's been happening in spacecraft and submarines for a long time. So it can be done. It's just very expensive in terms of energy and in terms of capital as well. So this is a way that could be scalable, but the question is about the cost of doing it, and the cost would be substantial. And then finally, this is another engineered method. This is just a pretty picture of some rocks, because rocks usually, when you do a picture of them, aren't that particularly interesting. This is quite a pretty one. But there are certain minerals, certain rocks, that when they weather, they take carbon dioxide out of the air. And this happens naturally, but happens very, very slowly. So there is an array of ideas which are looking at ways in which you can accelerate the rate at which rocks weather and thereby draw CO2 out of the atmosphere. As I say, I work at the university. I look at all these different techniques. I'm now going to also talk about the technique that my company is pursuing. So just declaring the conflict of interest there. So we have technology that can take carbon dioxide out of the atmosphere. And the process that we use involves the lime cycle. So you start off with calcium carbonate, limestone, heat it up, and that drives off CO2. And at this point, you're probably thinking, I'm mad. I thought we were trying to get rid of CO2. Why are you driving off CO2? But the point is, we're producing pure CO2 out of this process, and that means that CO2 can be buried underground. And then you also get lime, calcium oxide. And calcium oxide will react with CO2, carbon dioxide, in the air, and it will remove that carbon dioxide from the air, and you go back to calcium carbonate. So each time you go round the cycle, you are using heat to drive off CO2 and bury it underground, and then you are taking CO2 out of the air. And this is a process that we are developing. We've got lots of engineering drawings. We've built demonstrators. This is a rig at Heriot-Watt University just outside Edinburgh in Scotland. And we've done a costing of a plant that could remove 50,000 tons of CO2 from the air. And it would cost about 12 million pounds, about 15 million US dollars, and occupy the space of a football pitch. So we believe that this can be done. This was looking at what it would cost the UK to get to net zero along the kind of trajectory that Miles was talking about. And you start off slowly and you increase. And by 2050, you could get to net zero in the UK. And we reckon at about 0.25% of GDP. So to give you an idea, in this country, we spend about 1% of our GDP on getting fresh water. We spend about 2% of our GDP on defense. So actually, this is not a crazily large sum of money, but you do need to pay for it. So yes, you do need to pay for it. So do we have the will? So I want to put this in the context of Africa. The role of Africa in this is the use of land to remove CO2 from the air. So I talked about these models that are talking about afforestation and biomass energy and carbon capture and storage. And a lot of these models assume that this will take place in Africa. And I think that's a bit presumptuous of the modelers because frankly, it's your land for a start. And also you have many other uses for that land. So there is something slightly strange about these models often made in places in Europe, where often there are laws that say you cannot bury CO2 or very limit the amount that you can bury CO2 underground, but then assume in the models that this is what will happen and will happen elsewhere. What you also have is stranded energy, and this occurs all over the world, but there's much of it in Africa as well. And what I mean by stranded energy is that there are places in Africa where energy is very, very cheap, but it's not worth extracting from the ground because it costs too much to get it to where there is a market. And if we're going to take CO2 out of the atmosphere, we're going to need energy to do that. That is absolutely crucial. We need energy to take CO2 out of the atmosphere. And if you have this stranded energy, this cheap energy, then you can use that because you can take CO2 out of the atmosphere anywhere. It doesn't matter where you take it out of the air. It can be done anywhere. So it's best to locate it where the energy cost is lowest. So that there may be a role for Africa there. There are also the right kind of formations and minerals in which you can bury CO2. So Miles was talking about burying the CO2 in the Earth's crust. You can either find pockets of liquid under the ground, salty water where you can store the CO2, or certain kinds of minerals, basalts, where the CO2 will react. And there are many of them around Africa. So Africa could have a role. And the emissions that Africa make currently is small in global terms, but the role that Africa could have in actually taking CO2 out of the atmosphere could be a lot more substantial. And there's every reason to expect and anticipate that the countries that are polluting more at the moment should pay the countries that clean up the mess to do so. But you have to think about the other use of the resources of land that you might have, and you may choose not to do so. And so these models, as I say, have this assumption that much of this activity would happen in the continent of Africa, but they should really talk to the people in the continent of Africa about that more. You also need to make sure that you get your monitoring, reporting and verification issues sorted out so that you know that the CO2 is stored permanently and that there isn't any fraud involved in it. And that happens all over the world. It's absolutely essential to get the trust in the system. And you need to have payment to do it. We can think of adding CO2 to the atmosphere as a pollution problem, that we are adding this, we're treating the atmosphere as a dump, we're littering it with CO2. We need to have a payment to sort that out. We do not expect the streets to sweep themselves of rubbish, or wastewater to treat itself, or nuclear waste to tidy itself away safely. We have to pay people to do that. We will have to pay people to remove CO2 from the atmosphere. It is naive to expect otherwise. So we're ready to go. We can do this, it's possible to do, but you do need to have a way in which you actually pay people to take the carbon dioxide out of the air. Thank you very much indeed.
Thank you very much, Tim. This has truly been very enlightening. Because we're a bit behind time, I will go to the next speaker, who is Pauline Anneman. Pauline is a senior policy analyst at the Africa Center for Energy Policy in Ghana. And Pauline, looking at Tim's presentation, where he clearly showed us sort of one of the solutions, which is carbon capture storage, and being able to capture CO2 from the atmosphere. One of the things he mentioned was Africa being sort of a possible place to store the CO2, but he also mentioned some of the challenges and all of that. So if I can ask, for a country like Ghana, right? Let me just start from, is Africa a viable place for the storage of CO2? What is your view on that?
Well, so this is a very difficult question to answer, because when Tim was speaking, he clearly mentioned the challenges of, the requirements of vast lands to store the CO2. And land also have alternative uses. And in Africa, much of the economic activities are agriculture-based by people living in rural communities who are already poor. And when you are taking land from people, it means you are likely to entrench poverty. So there's a huge social angle to this whole discussion about taking lands from Africa, to store the CO2 that we must critically assess. And I'll use examples from the mining sector to explain my point. So for example, in Ghana here, we've had instances of compulsory acquisition of land for mining, because there is the public interest in there. Mining will bring more revenues for investment in development, so people have to give up lands. But people give up lands and they have to be adequately compensated, and the compensation must be on time, and then they must be put back in their former situation. So they must not be left worse off. But the evidence on the ground is completely different. You see so many people losing their livelihoods and have no better alternative livelihood. So poverty is further entrenched by the acquisition of land for extraction of resources. Now, if we have to bring this analogy to acquiring land to store carbon dioxide, then there's that angle that we have to make sure we address. Paying people, Tim kept saying you have to pay people to store the carbon. But the truth is that paying people may never be enough to sustain their livelihoods. While you are saving the globe from global warming, you realize that the people you are protecting from the global warming must also survive. And paying them may not be enough to put them in a position to excel in life. They could be made worse off. So there should be that level of consultation and serious social impact analysis before we decide on which areas to acquire lands to store the carbon dioxide. And then the other thing also is that from evidence and from science, we don't need just any land to store the carbon dioxide. Land must possess certain characteristics. There must be a permeable rock. that is overlaid by an impermeable rock, so that when the CO2 is pumped down, deep down the earth, it doesn't come out. We want to store it down the earth forever. So the question also is, which areas in Africa would be suitable for this kind of storage? Now we have the Sahara Desert, which appears to be not in use, but is that vast land area suitable for the storage? This is an area where people don't live in, and the impact on humans may be less, but the quality of the geology, does it support the storage of CO2 underground? Now, if you have to bring it to where people live, the question is, can people survive? Would they do well economically, socially, when you acquire the lands to do this? So this is a very difficult question that must be critically assessed in order to ensure that there are no losers and everybody is a winner. So Pareto efficiency must happen.
Thank you. Thank you very much. Thank you. So I'll go on to the next question. I don't know if, Tim, you want to respond to that in a way, or, but I'll go on to the next question. The next question for you, Pauline, thank you very much for that answer. The next question is, can a country like Ghana decarbonize by 2050? And as you saw from Miles's presentation, we need 100% decarbonization by 2050. Can we do that?
Okay, so before I move on to answer that question, we first have to ask the question, why are we focused on CO2 and not any other greenhouse gas? Because there are other ones like methane, nitrous oxide, industrial gas, chlorofluorocarbons and all that. So why are we focused on CO2? So it's simple, CO2 constitutes like 75% of total greenhouse gases, and it stays in the atmosphere for many, many years. And it is one that is contributed mostly by human action. So if we want to reduce emissions in large quantities, we need to focus on that CO2 and reduce human actions. Yeah, so that is just by the way. Now, can Ghana achieve decarbonization by 2050? It's a very, very, another difficult question to answer, because I will discuss Ghana's context, looking at our hydrocarbons, our energy mix, where we want to go with our natural resources, and the argument that Ghana has not emitted much and that we need to get the opportunity to develop, to industrialize. But Miles made an important point that even though African countries have not emitted much, we saw from the images he showed that we are actually experiencing global warming. So it is equally our business. We need to work to bring the temperatures down. That means it is in our own interest to put measures in place. So whilst we make the argument for industrialization and economic growth and extracting our natural resources in an optimal way, we need to make sure that we are also putting in place measures to bring down the carbon dioxide. So
I think Miles has something to say.
Okay.
I just wanted to stress also, just to point out, people talk about Ghana emitting, and that always makes me a little uncomfortable. I mean, Ghana doesn't emit. I mean, companies that are operating in Ghana are generating products that are sold to other countries, and there may be emissions associated with those processes. And so I think increasingly we need to get away from this notion of countries being responsible for emissions and focus much more on how companies are the real actors in this space. And indeed, companies and their customers are the people who are responsible for these emissions. And so instead of sitting around and sort of talking about how, your country's emitted more CO2 than my country, which of course Britain will always lose that argument because Britain started emitting CO2 before everybody else. We need to focus on the responsibilities of companies and their customers. And I think that could be a much easier conversation to have. So I'm thinking about the companies that will potentially be involved in exploiting the new fossil fuel reserves that have been discovered in Ghana, which is clearly a huge boost to the Ghanaian economy. But how are those reserves going to be exploited? Are you talking to those companies about what they're going to do with the carbon dioxide, which is generated by those fossil fuels, and thinking ahead so as to make sure that those fossil fuel reserves are not going to get stranded in a world as it makes the transition to net zero?
I have a rebuttal to Miles's point. He made a very brilliant point, which is amazing, and I agree with him to some extent. So I don't believe that any country can come to Ghana and operate without the country's consent. There are processes and procedures in place. And you mentioned the customers of these companies. The government of Ghana is actually a customer to these companies because we take gas to power our plants. And we've entered into a take-or-pay agreement to do so from ENI. So we are actually customers to these companies. Then whatever the companies do must be checked by the government. So we have, Ghana as a country has an obligation. So when the discussion about emission comes in, there are many stakeholders, involved. And we cannot only blame the companies. Governments have responsibilities. They are the ones that went to sign the Paris Agreement, right? So that is my rebuttal to Martin.
That's fair enough. I wasn't saying that I'm not saying you weren't important in this discussion. What I was saying was that I thought I get uncomfortable when people sort of blame countries for their emissions, because very often it's more complicated than that. A country is developing in such a way that their activities and the products they provide to other companies are associated with emissions. But then whose fault are those emissions? I don't think the blame discussion is very helpful. So
I agree. It's a shared responsibility. A shared responsibility.
Exactly. It's a shared responsibility.
So I agree. So thank you, Miles, for your contribution. It's amazing. Okay, so I'll move on to still give the context of Ghana for us to understand whether or not we can decarbonize by 2050. So when you look at the energy mix in Ghana, it's interesting to note that about 93% of our total energy mix is from burning fossil fuels and from burning organic matter. So petroleum contributes 41% to our energy mix in terms of the sources of energy. Biomass is 40%, natural gas is 12%, hydro is 5%, and others like solar 2%. So you see that burning organic matter that contributes high CO2 to the atmospheric gases is very high in our energy sources. Now let's come down to electricity generation. Ghana is one of the few countries in Africa that has crossed the 50% electricity access mark. There are only 7 countries in Africa. Ghana is one of them. South Africa is first with 91% access rate, and Ghana follows with 85%. And the interesting thing about these statistics is that both South Africa and Ghana, which have high access rates, generate this electricity from petroleum and coal, like those fossil fuels that we are talking about. So, but we also know that Africa needs to develop economically, and electricity access is very fundamental for our transformative growth and development. And so increasing access by all means must be done by government. And the data shows that those governments using the fossil fuel are the ones with the access. So there is that tension. How do we ensure that people have access to electricity and at the same time we protect the environment? So the argument about renewable energy coming in, to fill in the gap and also to, phase out the fossil fuel is very important. And that also depends a lot on technologies that are also cheaper, to make sure that we are able to achieve SDG 7 in Ghana and other African countries. Now, let's talk about the oil and gas sector in general. If you look at our oil and gas sector, we currently have 3 fields that are producing. We have the TEN, the Jubilee, and the Sankofa Ginyame. We have those fields producing both gas and crude. And beyond the production, we have revenues coming out of the production. So as we speak, we have generated about 32 billion Ghana cedis in revenues from oil. That is around $5.7 billion. And this money has supported education, it has supported health, it has supported agriculture, investments in agriculture, it has supported infrastructure. In fact, this year alone, in this year, the 2020 budget expected that oil revenues will contribute about more than 50% to the government's free SHS policy, free senior high school policy. And we've seen how the policy has benefited people who would otherwise not make it to school, who would otherwise not get some form of education. So that's the challenge we have now. The fossil fuel is generating revenues that are used to invest in those areas that would ensure that people have equal opportunity in life. So how do we address the challenge? Another point I want to make about how important, or the importance of oil and gas to Ghana's economy, has to do with how our economy was affected as a result of COVID-19. The government estimated budget deficit of over 9.9 billion Ghana cedis. And out of that figure, about 53% was coming from oil. So you could see that the country is so reliant on revenues from oil, such that even in this situation, the COVID-19 situation, our economy is so hit. It happened in the past 5 years ago, in 2015 and 2014, when oil prices went down. It shows how dependent we are, and it also speaks to the need to diversify. Now, speaking from the need to diversify, the government of Ghana is again trying to use the oil and gas sector to ensure that there are linkages to the rest of the Ghanaian economy. Yeah. So the sector is still central to diversification, linkages, local content, ensuring that businesses, entrepreneurship grows in this country through the oil and gas sector. There's manufacturing sector also grows because they have to feed supplies to the oil and gas sector. So building capacity and technology transfer. These are all ambitions of government. If you look at government policy, this is where we are going with our oil. Now let's look at the use of gas to power our economy. We have a national gas plan, and that was, I think it's dated 2019. And that plan also tells us what our priorities are for our gas. The topmost priority is to supply gas to power the economy and make sure that we transition. So gas is seen in Ghana as a transitioning fuel. It is very strategic for expanding energy access, right? And then there are also other sectors. We have plans to have a petrochemical industry. We want to make Ghana a petrol hub. So the master plan details out all these things. We also have plans to even export gas to other neighboring African countries, or generate electricity, export the electricity generated from gas to neighboring African countries. So that is the strategy. Of course, there are a lot of challenges with using our gas to power our economy. Infrastructure challenges, lack of market for it, difficulty of our state institutions to be financially credible to take out the gas and all of that. But the central point I'm trying to make is that in Ghana, in spite of the country signing on to the Paris Agreement and, putting together our intended nationally determined contribution, we see that the government has plans to use the very fossil fuel we are talking about as contributing to greenhouse gas to expand the economy, to create more opportunities for people. So we are in a very difficult challenge, but there is also a way out. Our government recognizes the need to, meet its obligations under the Paris Agreement. And so we also have a renewable energy master plan. We set targets for ourselves that by 2030, the energy mix should constitute 10% renewables. And the progress is very, very slow, to be honest. And
I was about to ask you whether it's achievable.
Whether or not it's achievable depends on the extent to which government can create the enabling environment for businesses to invest. As it stands now, our utilities are facing a lot of financial challenges. And so, we have a lot of capacity installed with thermal. About 63% of our electricity is generated from thermal. And about 30% also is from hydro, and then the rest from renewable, about 0.5% from renewables. So the government is in a very difficult situation right now to provide the right incentives for the renewable energy companies to invest and sell to Ghanaians, and for the energy to also be used in a very productive way so that they can recoup their investments. So these are the challenges. We really need to sit back and look at the whole scenario again and see how renewables can properly fit. But there is opportunity. There's opportunity for renewables in the country, and government is working so hard to make sure that renewable features.
Okay, so fantastic. Thank you. Thank you very much, Pauline. I think we're right. We have just 10 minutes for questions. And so, Tim, we have one now, and I'll go straight to you. I know the mouse is answering some already on the system. So, Tim, we will ask you, this is from Bernard Day Sechi. What is your take on bearing carbon and its potential effect on increasing earthquake occurrences?
Okay, so where you would want to store carbon under the ground, you would look for a stable geological formation. You would choose a place where you wouldn't cause problems. Injecting any fluid into the ground is going to cause some seismic activity, but we're talking a very small amount. There are tremors all over the world every day of a level that people don't feel. And you would certainly want to inject CO2 in places where people wouldn't feel any of the very small tremors that you would produce. We have to recognize that this is a kind of risk analysis. There is a risk of leaving CO2 in the atmosphere. It's called climate change. There's a risk of injecting it in the ground. And what you need to do is you need to make sure that the cure is better than the disease that you're attempting to cure. But it's certainly possible to do it in a way that you can minimize those risks. And you would probably do it away from where people live. So underneath the seabed or in areas where people don't live.
Fantastic. Thank you very much. Pauline, another question has just come for you to you from Facebook, from Asiyi Nonu. And the question is, does Ghana find it important to decarbonize?
Yes, the government finds it important to decarbonize. That is why we've made commitments under the Paris Agreement. And if you look through our document on the nationally determined contribution, we've set targets for ourselves. And we are looking to invest in, so we are looking at different sectors of the economy where we can decarbonize. So we have the energy sector, we also have transport sector, we have provisions on waste management. We also have provisions on how to manage CO2 emissions by the industries. So within the energy sector, for instance, we are looking to, apart from scaling up renewable energy by 10% in 2020, which also has its challenges that government is really working hard to address. We are looking at ensuring that rural people living in rural communities have access to clean electricity. And government has put in initiatives of investing oil revenues in the past in solar lanterns and distributing these to people in rural communities. We also have government putting in place off-grid, working together with private investors to see how we can provide off-grid electricity access solutions to people living in the hinterlands. We also have our state companies like the Bui Power Authority and the VRA also investing in solar. They have invested in solar. Bui Power Authority has also invested in mini hydro dams. The government has also invested in, there are plans to invest in rooftop solar solutions. So the government is really keen on, bringing in more renewables, reducing CO2 emissions. And with the transportation aspect, we intend to encourage mass transportation that is also sustainable environmentally. We know when people pull, when there is a carpool, for want of better word, there is the possibility of reducing emissions from driving individual cars. But this aspect is also an area that needs a lot of careful review, because our state transport corporations are struggling. They're actually struggling to survive in this country. We have private entities or private individuals operating, private commercial vehicles. But these also, there's large emissions from this. So there's the need to have that conversation between private sector and the government on how to move forward with the transport sector.
Fantastic. All right. Good. Thank you very much. Mouse, we come into you for, sorry, yes, there's a question from Praveshni. I think he's the same guy that has sent another question. But this is, how can financial institutions aid in achieving, 1, the net zero emissions, and 2, climate resilience? I think he must join the webinar on the Oxford Martin principles as well. But here you go, Mouse. That's the question.
Yeah, so, well, the first thing financial institutions can do, because, these particularly institutions like pension funds and so on that invest, or sovereign wealth funds that invest on very long timescales, one important thing they can do is just to recognize publicly where we're going. And it is actually very helpful that the financial community is coming out and saying that they understand what's going on and that they support this transition to net zero. And that in itself sends a very strong signal to companies what the way companies should be planning ahead on this. But crucially, of course, if we're building most of the plants that will generate emissions in the second half of this century is being designed or commissioned today, whether it's power plants or more sort of not things you might not think of as energy infrastructure, but a road network is an energy infrastructure, or a city design, a city plan is an energy infrastructure, because it commits us to emissions in the future just by the way cities are designed. So where financial institutions can really make a difference today is to look at their loan book and ask themselves, what is the emissions commitment of our loan book? What are our loans? How are our loans that we're making to developing countries? What are they doing to commit those countries to emissions in the future? And crucially, are we necessarily doing those countries a favor by lending them money to build assets that might actually lose value in the future in a net zero world? And this is something that I think, financial institutions need to be increasingly conscious of, is making sure they don't lend money for companies to, for countries and companies to build plants that simply won't make economic sense in a net zero world. And again, this circles back to the sort of obligations and the opportunities in the fossil fuel industry, that the way to exploit fossil fuels responsibly and safely in a net zero world is, of course, to dispose of the CO2 along with extracting the fossil carbon. Tim has shown that's perfectly possible, but unless financial institutions give companies a steer in that direction, it can't just happen organically on its own.
Fantastic. Thank you. Thank you very much. I think we almost on time. I'll just give another round just for 2-minute summary of everything, Mouse. 2-minute summary of everything you've said today. Yes.
Okay, so I really enjoyed Pauline's interjection there, and actually that was really interesting to hear the Ghanaian perspective. And you know, it's really important that Ghana is very engaged with climate talks. I remember having been to some of these IPCC meetings and also to the UNFCCC meetings. You ought to be congratulated actually in the sort of level of engagement that Ghana is taking in the climate negotiations, and also the fact that like many countries in Africa, Ghana has really taken this on board and has made sure that at all levels of government, people understand what's happening on the climate issue. So that first investment has been made, and that's great. But the next stage is planning through to the future and planning for what Ghana is going to look like in a net zero world. Exactly. We can argue about what date you're going to get there. I mean, and I can completely understand the argument that Britain has a duty, which is actually accepted by the British government, that we have a duty to get to net zero first. I mean, we started this, we should be the first to stop it. That's entirely reasonable. But at the same time, at some point this century, the world has got to get to net zero. So countries, particularly countries with substantial fossil fuel resources, need to think about what are they going to look like in a net zero world? How are they going to continue to exploit those resources, to make the most of them, to capitalize on them in a world where we can no longer dump carbon dioxide into the atmosphere? So it's that planning ahead, thinking down the line, and thinking about how the burden and the responsibility for making that transition should be shared is something I think we can all do together going forwards. And I look forward to carrying on with this conversation. Very nice to meet you, Pauline.
Fantastic.
Now we you too, Miles.
Fantastic. I think we go to Tim because you know, we go to Tim to also just give us his views. Just 2 minutes, Tim.
Thank you very much, Rachel. Thank you very much, Rachel. So I really enjoyed the talks. Thank you very much for inviting me. I think that the key point that I would make is if we are to achieve the Paris Agreement goals, we will need to get to net zero. And in order to do that, we will need to take CO2 out of the air. That will have to be paid for somehow. And it makes sense that the polluter pays, the people who are producing the problem and have produced it in the past pay for that. So there will either be, we will achieve those Paris Agreement goals because there are mechanisms in place to incentivize people to take CO2 out of the air, or if those incentives aren't there, then we're not going to achieve those goals. If those incentives are in place, then Africa has a key role to play. It has natural resources. They can actually be a net beneficiary of money going to them to actually store CO2 underground. And I think that countries like Ghana that have fossil energy shouldn't be afraid of this, because actually you can use that fossil energy to take CO2 out of the atmosphere. So what we're working on, for every ton of natural gas that you get out of the ground, you could actually take 8 tons of carbon dioxide out of the air and bury it away. Yeah. So in a world where there is value for removing CO2 from the atmosphere, actually it's the people who have the fossil energy who could actually benefit from that by actually playing a role in curing climate change rather than causing it.
Fantastic. Last one, Pauline, your last thoughts?
Yes, my last thought. So it is good that the Paris Agreement is something that is voluntary, that countries must see the need to do it. The problem with it is that it depends on countries' conscience. So a country may be emitting more, but they may decide not to, like the US withdrew in 2017, you know. But from Miles's presentation, we have seen the need for countries in Africa to take climate change issues seriously. And that means that whilst we extract our oil and gas resources, we must make sure that we balance that off with investment in renewable energy. It is very important that the government of Ghana is already on the right track, but the key challenge is the financing. The government, if you look at the document on our nationally determined contribution, we want to contribute less than 30% over till 2050 to curb this climate change problem, and that is not enough. And it is clear in the document that we need a lot of financial support because, let's face it, African governments have a lot of responsibilities. Most countries have not been able to meet the basic needs of their citizens. So investing in climate change initiatives is another burden on its own that they don't see as a priority. But when we are supported in the right way, it is possible that we can achieve the net zero emission we are looking at. And so the point about the polluter pays is very, very important. And it is important for government in Africa to figure out the exact approach to making this the polluters pay. And people have argued about, carbon pricing and all that. But in our African context, the question is, will that really work for us? Do we have even the right technology and the human capacity to determine the exact price to put on emissions by companies? And even if we are able to do that, when companies pay their monies to government, will government really use the money to take out the carbon dioxide and bury it with the right technology, or they'll use the money they'll invest the money in education and health and those things, and then the carbon remains in the atmosphere? So there are various tools to do this. One way is for African governments to require that before a company comes in to extract our mineral resources, our laws must require that they must have the right technology. And that technology includes how they want to take out the carbon in their extraction processes. The same goes to entering into agreements with power producers and etc. So we have to be innovative about this. But the truth also is that, burying the carbon only contributes about 10 to 50% of the effort in removing the carbon emission, according to the IPCC. That means there are other means that we can remove the carbon. We need to pursue all means. I am for all possible means. Let's pursue every available means. And governments must pursue renewable energy. It should be a priority, but we must try to balance that with all the other sources of energy that we have.
Fantastic. Thank you. Thank you very, very much. Very well spoken, Pauline, and very well spoken, everyone. From what we've heard today, we know that the Paris Agreement is very important for us to meet the 1.5 degrees, as Professor Miles has said. We need to decarbonize by 2050, 100% decarbonization. We know that this is not easy, especially for African countries, but we know that African countries stand to suffer the most from the impacts of climate change. And the solution for us and for companies is probably the carbon capture technology that Tim has also spoken about, which is very important. And yes, it is very debatable, but maybe African countries can also make money from the carbon capture technology, the storage of the CO2. So definitely it is very debatable, and it requires African countries to take a seat at the table at the IPCC and also engage in a lot more research that, that can be used to inform policy and also engage more. So I thank you all very, very much. I know that majority that have tuned in are from the financial markets, and this may have at times seemed a little bit technical, but we have to understand the science behind the climate change before we can actually apply it, which is very important. And I thank everyone for joining today. If we were not able to answer your questions, we will try and answer some of your questions later on. We will probably respond in an email to you some of the questions. I think we've managed to cover quite a lot that that were asked through the registrations that occurred. But surely we're truly grateful to everyone who attended, and thank you all. Thank you very much, Miles, for making this possible. Pauline, thank you, Tim. We're truly grateful for you to have joined us today.